Welcome you all to the Research Spark YouTube channel. This is the part second of the course Signal Processing of the Unit Second. So currently we are running in the Unit Second, that is the analysis of continuous time, CT, signals and system. Here is the outline of this session. So mostly we'll focus on the frequency response followed by the impulse and the step response of the LTI continuous time system using the Fourier transform. So first, what do you mean by exactly the Fourier transform of your continuous time signal? So suppose xt is any continuous time signal, and then the frequency response or the Fourier transform of your continuous time xt can be defined as the integration over minus infinity to infinity x of t e to the power minus j omega t dt. So this is how to find out the Fourier transform of any continuous time signal x of t. So simply, what do you mean by the frequency response? So frequency response is nothing. This is your h of j omega characterized how the system modifies the amplitude and phase of each frequency component of the input. In simple, like frequency response will give you the idea how your system will vary depending on the inputs. So if you know the frequency response, then corresponding to the different inputs, it will be very easy to find out the output. So mostly we are talking either about the frequency response of the some example. So here let's suppose the h of t. Mostly we are representing it as h of t, and the corresponding Fourier transform will be h of omega. So suppose h of t is equal to 1 by RC e to the power minus t by RC. So this is your RC circuit only. So you can consider it as h of t. So what will be the Fourier the frequency response, that is h of j omega. So you can see here h of j omega will be equal to the 1 by RC into 1 divided by 1 by RC plus j omega. So this will be the frequency response of h of t, that is exactly the RC circuit having the equation 1 by RC to the power minus t by RC. So this is the frequency response. Now mostly in our syllabus we are going to talk about the two response. First is the impulse response and second one is the unit step response. So first, what do you mean by this impulse response? So impulse response is simply when if you have the some frequency response like h of t, and if your input is del of t, that is the impulse function, then the output is exactly called as the impulse response. Simply if you have the some h of t, that is frequency response, and if you are giving the some input that is del of t, means impulse function. Since we are giving the impulse in the input, that is why this is called the impulse response. Similarly, if we give the step in the input side having the frequency response of h of t, then this will be the step response. So let's see here how can we find out the impulse response. So simply the finding the impulse response using the inverse Fourier transform. Like if you wanted to find out using this inverse Fourier transform, then you can find out the h of t will be the f inverse of h of j omega, that will be equal to the 1 by twice pi minus infinity to infinity h of j omega e to the power j omega t d omega. So this will give you the inverse Fourier transform. And if you wanted to find out in the frequency domain itself, then simply multiply the del of the impulse function, that is the 1 into your h of omega. So that will be simply the h of omega. As for example, suppose here h of j omega is equal to 1 divided by 1 plus j omega RC. This is the frequency response of low pass filter exactly. Now if you wanted to find out the impulse response in the frequency domain, then this will be your simply the same values, that is 1 divided by 1 plus j omega RC. But if you wanted to find in the frequency domain, then just take the inverse response, inverse Fourier transform, and you will get the value something like 1 by RC e to the power minus t by RC of ut. So this will be the frequency response in time domain. Now let's talk about the unit step response. Since impulse response, like we are giving the input as a impulse function, similarly in the unit step response, now we'll give the input unit step function in the input side. So again, the output will be definitely the convolution in the time domain, the convolution of the unit step, that is a u of t into the h of t, that is the frequency response. Now in the time domain, in the frequency domain, the simply it will be the product, the multiplication of your frequency response, that is h of omega into u of omega. So that will be the frequency, the unit step response. Now here consider an example. Suppose frequency response low pass RC low pass filter having the frequency response similar to that previous one. H of omega is equal to 1 by 1 plus j omega RC. And so what will be the frequency response? Step response simply, since this is the frequency response is h of j omega, so the again if we have wanted to find out in the frequency domain, then the step response output will be the h of j omega into u of omega. So here u of omega is equal to 1 by j omega, and h of j omega is 1 by 1 plus j omega rc. So simply product of unit step response and the frequency response will be the unit step response of the particular function. Now, if you wanted to convert it into the time domain, then you can convert back using the inverse Fourier transform. Finally, output will be 1 minus e to the power minus t by rc. So similarly, we can find out the step response or the impulse response for any functions having the frequency response of h of j omega by using the same technique, that is y of t. If output is something y of t, y of omega, then that will be in the frequency domain will be the product of u of t or any response into the h of t. So here is the some responses. So frequency response obviously and the impulse response both will be same if it is in the frequency response, or if you wanted to convert in the time domain, just use the inverse Fourier transform. As for example, for RC low pass filter, the inverse Fourier transform will be a 1 by RC to the power minus t by RC. And here are the some more examples. Just check this. So that's all in this session. In the next session, we will talk about the Laplace transform, inverse Laplace transform, region of convergence, that is ROC, and the properties. Thank you for listening me. And if you have any doubts, please drop your comments. Thank you.